So hello everyone. So this is the Transportation Engineering Sessional I. We will be learning in this course, and that is entitled the course known as CEE 4652, as you all know. In this course, this is very much important course for the transportation engineers as well as the civil engineers, just because we will learn some basic experiments which we must conduct in our later career as well in the field of transportation engineering. And as you all know that the transportation engineering is the major field in the engineering division, obviously in the civil engineering division as well, in regard of Bangladesh, just because if you see all the roadway, all the budgets are basically focused on the transportation engineering fields, although there are structural aspects as well, but if you focus that the structural engineering or whatever we say, the structure of building infrastructure, there are basically concern of the personal interest, just because you see the building constructed by the owner of the building. But what happens when we'll be asking about the roadway, the pavement? Whenever we are asking about the pavement, obviously this is most likely, obviously it is going after the public interest, and that's why the public authority, the government authority, the most significant authority in civil engineering division is the transportation engineering division. So if we say about the pavements, we can roadways, we can divide the Bangladesh roadways into six major types. Six types of roadways we can divide, and there are two major authorities who are the caretakers of these six types of roads. So those authorities are RSD, Roads and Highway Department, and LGED, Local Government Engineering Department. These two authorities are the relevant authorities of these six types of roads. What are the six types of roadways in Bangladesh? You can divide. Obviously, the first one will start with national highways. National highways, you see as example of Dhaka Mymensingh Highway in front of our IIT, the roadway, that the national highway, that is the Dhaka Mymensingh Highway. This kind of highways are called national highways, and there are other kind of road, that is regional highways. Okay, so beyond this there are Jila roads as well, Jila roads and Upajila roads. Then there are Union roads. Okay, and also the village roads as well. The village roads. So these first three highway and Jila roads are under supervision of RSD. They generally maintain these things, and these latter three things are maintained by LGED. So these two authorities are responsible for all these roadway types in Bangladesh. So, and if I say this is the most significant division which have most engineers deployed in Bangladesh, and obviously RSD as well, but not as the extent of LGED is. However, the national highway, regional highway, and the Jila roads, these three are supervised by RSD, and the later three are supervised by LGED. So we have a concern regarding these highway roads, just because whenever we want to construct a new pavement, we need to construct pavement. So we need to maintain, and sometimes we need to remove as well. So While doing these jobs, we need to undertake some tests of the pavement. And beyond this, we have also another aspect, that is the traffic engineering, where we deal with the number of vehicle, the speed, density, all of this within the pavement of the vehicles. So traffic engineering is another part of this. So using all these things, we can use this transportation engineering sessional as a beginning of our experiments. And obviously there, if we sort out, you will find at least 200 plus tests are there for transportation engineering. So we cannot cover all those transportation engineering sessional and experiments in this course, and even there are some tests as well which we cannot remember the name, we haven't heard of those names by this time. There are some tests like this. So however, we will be focusing some major tests in this course, and we will be expecting that this popular test will have to be conducted very frequently in any cases. That's why this is the beginning, and we can expect that using this knowledge you can explore your knowledge further, and whenever the new test will arrive, using this knowledge you can upgrade those knowledge as well. That's how the course has been designed. So basically in this sessional, still even we have reduced the number of experiments here. We have reduced it up to 16 number of experiments from 200 plus. So again, this is not a very less number to conduct. So there might be classes where we'll have to conduct multiple tests at a time. So be prepared for that. So don't worry, we'll be covering all the topics hopefully, inshallah. So we can divide what I was saying, that we can divide the total session of the experiments into three major types for this course. First one is regarding the aggregates. The aggregates we use in pavement. As you all know that in structural engineering we use aggregate, coarse aggregate, fine aggregate for the building construction or infrastructure. And in transportation engineering, whenever this is, we are dealing about pavement, aggregate is must. So test of aggregates will have to conduct here. Also you have conducted some aggregate tests in your material sessional, I hope, material sessional before. But in this sessional we will be particularly focusing on the aggregate tests which are not covered in your material sessional, in addition to material sessional. And don't think that the tests we have conducted in material sessional are not relevant with transportation engineering. Obviously they are relevant, and we will need to focus on those knowledge as well. In addition to that, this test will be conducting in this sessional. Okay, so the second one, I say the most important one, this is the bituminous material test. Bituminous materials test. So this is another vital test. As you all know that the roadway, throughout the roadway, wherever we see bitumen and bitumen, asphalt or bitumen, whatever we see all around us, the roadway are bituminous. So that's why the bituminous tests are there. We have to learn the test we need to conduct regarding bitumen. And the third one is the traffic engineering session. So we'll be just introducing the traffic engineering sessionals, 2 or 3 basic sessional test experiments regarding traffic engineering in this course. So we don't have any soft copy of the Transportation Engineering Sessional I manual, so we always recommend you to collect this manual from the IoT lab instructor in our Transportation Engineering Sessional room. But as we don't have any soft copy, we cannot provide it. So please try to focus on the lecture we are giving, and whenever you will be able to collect the manual, we can discuss about it later on how we can collect it. So then you can focus on those materials afterwards. But before that, please focus on this study. So we will be conducting, if I sort out the names of the test, we will see here. First one, we can say the determination of aggregate impact value. Determination of aggregate impact value. Second, the test will be determination of ACV, aggregate crushing value. The third test will be determination of 10% fine value. There is another test, determination of flakiness index. Also there is determination of elongation index. And another test is determination of angularity number. Then we can start the specific gravity, and from here we start the bituminous material. So specific gravity of semi-solid bituminous material. So this is the 7th test. The number 8 test is the penetration of bituminous material. So penetration test, you can say penetration test. After that, we can say about the ductility test. After that, the softening point. Test. After that, flash and fire point. Test. Next, loss on heating. So whenever we provide heat to the bituminous material, there will be loss of some of the weight of those materials. So that is the loss on heating test. Then we'll see two important tests, one of which is CBR, the California bearing ratio test, and another one is the Marshall method of mix design. So these all are the tests regarding bituminous materials. So number 15. Number 15 test will be, so as we have come up to number 14, So we'll add two more tests. Those two will be regarding traffic engineering. So determination of roadway capacity. Determination of roadway capacity. So roadway capacity, that will be the first test of traffic engineering, and another will be the measuring of saturation flow at traffic signals. Although I don't know whether you have by this time completed the Transportation Engineering 1 theory course or not. If you have completed it, you should know something about these things, and even if you have not, then we'll be discussing it in our relevant classes, respective classes, so don't worry about that. So this 16 test we will be conducting throughout this course. So now obviously about the course marks distribution, if I say so, marks distribution, obviously there will be marks in your attendance, obviously submissions of the test reports, obviously there will be marks in your quizzes. So we'll likely to take two quizzes, one after mid and one after the before the final semester, and so two tests, two quizzes likely will be taking, and there might be sudden quizzes as well, or MCQ or bonus mark provision for you as well in this course. However, so be attentive to the class in addition to be attendee of the class. Obviously submit all of your test report, as we just because we don't know how to submit this report in this environment or in this situation. That's why we will keep this submission for a while, or we can discuss about it later on. However, if there are submissions, you will have to submit collecting data and writing the reports. There will be marks on this submission, and we'll be taking the quizzes, and based on this we will be distributing. So likely let will be giving 15% to the attendance, and quiz will contain the lion's share of the course, and submission obviously that will also contain about 15 to 25% of the course marks, and the remaining will be in the quizzes. So obviously you'll have to focus in your studies. So today we will be starting with the very first experiment, that is the determination of AIV, Aggregate Impact Value. What is AIV? Aggregate Impact Value. That is called the AIV test. So as you all know that the pavement is continuously subjected to the repetition of loads over this. If there are vehicles over there, so continuous repetition of loads on a pavement, as much as all the vehicles going there. So at a particular point there will be a repetition of load, and obviously those loads are likely to be impacting upon this, the pounding load. So that will not be statically just increasing the load gradually, rather than there is no load here, all on a sudden there will be a vehicle over there. So there are situations where the impact load will be there on the pavement, and as you all know that the pavements are made up of what? Aggregates and bitumens will be used to combine the aggregates within a specific area. So these aggregates, whenever are subjected to impact loads, if impact loads are there, so these aggregates will break. there are possibilities of this aggregate to be broken. So using this test we will try to find out the quality, the property of aggregate, how it behaves under impact load, how much of this aggregate is broken into pieces or into small pieces. We'll see using this test. The AIV is generally indicating a value, a unitless value which has no unit. And whether the value, if it is higher value, whether it is good for us for the construction or not, and if the value is lower, the small, whether it is good or bad, this is up to you, your decision. So based on this decision we will see whether we will be applying these aggregates on our pavement or not, whether to accept, whether to reject, whatever we will be learning here. So this is the aggregate impact value. The AIV value generally indicates after the impact of load within a combination of aggregate, how much portion of these aggregates are broken into small pieces or fine, you can say. So that value, the percentage value, in a sense indicates the value of aggregate impact, that is AIV. So in this regard we can say as much the value of AIV rises, we can say the aggregates are of that quality. We cannot expect this kind of aggregates. So if AIV is greater than 30, we generally do not recommend this for our roadway construction, and in this case this result will be anomalous. That is, the result will vary each time in great proportions. Whether first of all, one time as you have conducted the test you will get AIV is equal to 35, and another time when using the same sample you will be conducting the test, you will get the value of AIV equals to 40 or 41 and sometimes 28. So great variations will be there. If you find AIV is greater than 30, that will indicate such kind of material or aggregate that is of bad quality. You cannot expect or recommend that kind of material. So as much the AIV value is less, that indicates that very few aggregates are broken into pieces, into small fine aggregates. So that's why we will be recommending those AIV. So in generally, whenever constructing any road or highway, we'll have some general instructions on AIV, the range of AIV which is acceptable, the specific, say for example 8 to 15 or less than 15, less than 12. There are some guidelines upon which we will be recommending accepting the particular sample, particular aggregate type or not. However, so for this test, the aggregate, there are some quality of aggregate before testing. The aggregate will be the size of aggregate will be in between 10 millimeter, less than 14 millimeter, and greater than 10 millimeter. So this is the aggregate size. So say for example the aggregate or aggregates will have a size of say 13 millimeter or 13.5 millimeter, all is okay, or it may be 11 millimeter, whatever it is, the aggregate size, it is okay. So after gradation, we will be for any sample, if we want to fix out the aggregate for this AIV test, what we need to do, we will be passing the aggregate through 14 millimeter, the aggregate which will pass through 14 millimeter and which will be retained on 10 millimeter sieves. Those aggregate will be sorted out as sample for AIV test. So this is the precondition of this test. Okay, so obviously you can conduct test less than 10 millimeter as well, but that in that case, this guideline, the guideline we are following for this particular test, will be no longer valid for us. Okay, so that's why then enter at your own risk. If you are using less than 10 millimeter size of aggregate, then enter it to your own risk. The guideline we are following will be no longer valid for us. Okay, so this sieve, 14 millimeter sieve, British sieve, obviously BS sieve, British sieve, 14 millimeter and 10 millimeter we are dealing with. So how to apply the impact load over this aggregate? For doing this, we need a cylinder. So we will need a cylinder, and obviously we need a hammer as well. So this hammer, we will be giving an impact load using this hammer to this cylinder from a specific height, and the aggregates will be accumulated in this cylinder in a specific manner. So after applying load, the impact load, this hammer, obviously this hammer has a specific weight. The weight of the hammer is fixed as 13.5 kg to 14 kg, that is 13.5 kg to 14 kg. Okay, so this hammer will be released from a height which is 380 plus minus 5. 380 plus minus 5 millimeters, or just because you cannot keep the exact accuracy from the surface of the cylinder, this top surface of the cylinder. 380 plus minus 5 millimeter, we'll have to apply this hammer. And how many times we'll have to fall this hammer? You will be giving total 15 number of blows. 15 number of blows we will be giving. So number of 15 blows will be giving using this hammer from 380 plus minus 5 millimeter height, and obviously the repetition will not be less than 1 second each. That is, this 15 number of repetition, say within 1 second, we cannot give 15 number, each number one after another, less than 1 second. So you need to wait at least 1 second after applying one impact load using this hammer. Then after that, you will again pull this hammer up to this 380 plus minus 5 millimeter. Then after 1 second, you can again give another load by releasing this hammer, but not less than 1 second frequency. That's how we'll be giving 15 number of those. And how to prepare this cylinder? We'll be filling up this cylinder with, obviously this cylinder has a specific obviously this If this is the cylinder, this cylinder has a specific inner diameter and height. Obviously, whatever this is, these are not very much important for us for our exam as well, but the height of the hammer, number of blows, or the weight of the hammer, these are important. Just because if we say, we can give some question in your quiz that how much energy is provided into the sample. So 15 number of blows, weight is there, the height is there, so you can easily calculate the number, the energy amount which has been applied to this cylinder during AIV test. So okay, so then you can take either 13.5 kg hammer or 14 kg. In between these two value, anything you can assume, or 380 you can standardly assume 380. So within this range, if you take those values and your answer are close to our expectation, then you will be getting marks. In your exam will not give the information that 15 number of blows should be given there, or 380 plus minus 5 millimeter height should be there. We will not give this information to you, so you need to learn these things, obviously these things, and not you don't need to memorize the height and diameter of this cylinder. So however, we will fill this cylinder with aggregates in 3 layers. 1/3 layers. First of all, 1/3 will be filled up, approximately 1/3 will be filled up with aggregate. Then using a tamping rod, there will be a tamping rod of cylindrical cross section which will be using 25 blows, even blows throughout this surface to make it plane, approximately plane. Then you will be again filling up the remaining 1/3 again, then again using tamping rod, again 25 blows. There are specific heights of these blows according to the guideline. Say for example, if I say the blows you will be give should be approximately 50 millimeter above the top of the aggregate layer. So if you are filling up the second layer, this tamping rod should be tamped within this aggregate from above about 50 millimeter height, then evenly distributed, okay, according to your eye judgment. Again 25 blows, and finally obviously fill up and again make it plain. So this surface then will be applied load using hammer, and obviously the weight of this cylinder you will have to take. There will be weight of cylinder before filling up, then weight of cylinder plus aggregate, this filled up aggregate. From this difference we will get the weight of aggregate, and that will be called the weight of aggregate. This portion that will be called A. Okay, in transportation engineering session, this aggregate or bituminous material test, there are some specification on the tolerance, up to which decimal or how to round the figures. There are some specific guidelines. So if you don't follow those guidelines, you will not be able to achieve the marks in the test. There will be test on you whether you can identify the values or not. We'll be looking there shown here. So a gram. So there will be balance which will be used to measure the weight of the aggregate. So whenever the sample A will be measured, we will be measuring this, rounding it up to 0.1 gram. So whatever the weight of A, that will be rounded to 0.1 gram sensitivity. So say for example the weight will be, say 357.3 gram. So this is possible for A, the total weight with aggregate in the cylinder before applying the load. And after that, whenever we'll be applying load using that hammer of 13.5 kg or 14 kg with 15 number of blows from 380 millimeter height, after that obviously we can expect the aggregate within this will be broken into pieces, and after that all of the materials aggregates within the as well as the fines which will be stored in the surface here and here, all will be taken to weight again in the balance. So before that we will be passing all these aggregates including the fines in a sieve of 2.35 millimeter. So initially what we have said, this was 10 millimeter to 14 millimeter aggregate we have used, and after that now we will be testing in 2.36 millimeter, sorry, 3.36 millimeter BT sieve. The passing the aggregates which will remain greater than this sieve will be retained on this sieve, and obviously there will be a pen over there where the aggregates or fines will be stored. So the weight retaining on this sieve, this will be called C, and the weight retaining passing through this sieve and retaining on this pen will be denoted as B. So we'll be weighting this B and weighting this C as well, all up to 0.1 gram precision. And after that we will be summing up, adding up B plus C. And if we see that B plus C is not equals to A, obviously it will not be exactly equals to A, but there is a specific guideline for this. If you see that the difference of B plus C, difference of B plus C and A is greater than 1 gram or less than 1 gram, plus minus 1. Okay, that is, if you say say A is, forget about this, if you say A is 357.3 gram we have measured initially, and B plus C, if you find that B plus C is 356.2 gram, then it will be rejected. Or even if it is 358.4 gram, then obviously again it will be rejected. This should be in between 356.3 gram to 358.3 gram. So B plus C, if it is within this range, that is not exceeding A plus minus 1 gram, then you will accept this value. Otherwise, if it exceeding this value like this one and this one, then a new test will have to conducted. Again, now what I like to say that this test, obviously if a successful test has been done, this kind of test will be done 2 times according to our guideline. So you will have to conduct the same test with the same sample of aggregate 2 times. So initially you will divide 2 equal amount of samples or likely equal samples, weight of samples from the same sample, representative sample. So first one and second one, 2 times we will be using the same test will be conducted, and finally you will get P by A value into 100, and that will be our AIV value for the test. Okay, so this is AIV, how to conduct, and B by A 100, this will be from the first observation B plus A, and second observation B by A into 100. So 2 value you will be getting. Now you will be taking the mean of these two. So mean of these two you will be taking. So you will be, how to take this measurement? First observation B by A into 100, this first observation, you will have to you will have to take it up to first decimal place. Obviously this will be a percentage indeed, as we have multiplied it with 100%. So whatever you get, you will have to record it up to first decimal place. Whatever it is, you will have to record it up to first decimal place. Say for example, this value you have got 15.283 something like this, but you will get it like 15, note it like 15.3, the first observation. Similarly 7 observation you may get 15.1 or 2, whatever it is. So from these two you will take mean of these two, and the mean will be rounded to nearest whole number. So not upper rounding or lower rounding, the nearest whole number. So you will have to report it to nearest whole number. So mean of this and this will be 15.2 as we know, and if we round it then we will get 15, and this will be reported as AIV. So this will be your answer. So in any case, if you just write down 15.2 as the answer, then you will get totally 0. We will not accept this answer. So very carefully focus on these things while conducting the experiment. There are specific guidelines on this, and in almost every experiment whenever we'll be learning those, I will be informing you about this placement, the rounding, how to report all those numbers. I will be guiding you, inshallah. So just follow these things, and in your quiz there will be test on this thing, whether you can report it correctly or not. Otherwise calculation might be very easy, B by A into 100, B by A into 100, and just averaging this thing. But this is not the end. Can you report it up to nearest whole number or not? That is the question. So as this is the first class of this course, so that's why I'm not going further. But in next class we might be focusing 2 experiments at a time, just because we'll have to finish all these experiments before, otherwise we'll not get enough time to complete all the 16 experiments. We'll need some week for quizzes, some week for 2 quizzes will be there, or discussion might be there. There will be experiments in physical manner whenever the IoT will be open. That's why we'll have to keep some spaces for this. We'll have to keep some time. That's why we'll be trying to complete the theoretical part as early as possible from the next classes. So thank you for being with us.